Hello students, in this video lesson pertaining to lines and angles chapter 6 part 7 we will be discussing the converse of certain theorems that we learned in the earlier video lesson. I want you to have a look at it. Now in the earlier video lesson we discussed corresponding angle axiom, alternate angle theorem and interior angle theorem. Now, what does the corresponding angle axiom state? If a transversal intersects two parallel lines, then the corresponding angle so formed will be congruent. If a transversal intersects two parallel lines, then the alternate angle so formed will be congruent. And if a transversal intersects two parallel lines, then the interior angles which are formed on the same side of the transversal, they will be supplementary. So what do you notice in these three? You will notice that the transversal is intersecting parallel lines. And when it intersects parallel lines, then the corresponding angles will be congruent, alternate angles will be congruent, and interior angles on the same side of the transversal will total up to 180 degree. Now what we are going to do in this video lesson is to prove the converse of these three which you see on the left hand side. That is, let us learn to prove the converse of corresponding angle axiom, the converse of alternate angle theorem, and how to prove the converse of interior angle theorem. So first and foremost, let us understand the meaning of converse of corresponding angle axiom. Now remember the following statement. I want you to take a notebook and write down converse of corresponding angle axiom. In the textbook it is stated as axiom 6.4, and this is the statement of the axiom. If a transversal intersects two lines such that a pair of corresponding angle is equal, then the two lines are parallel to each other. So what does this statement mean? If a transversal intersects two lines such that a pair of corresponding angle is equal. Now let us take a pair of corresponding angle. 120 degree and 120 degree. These two angles are corresponding angles and they are also congruent. They have the same measure. Then what can you tell about these two lines? These two lines will be automatically parallel. That means if you come across a diagram where there is a transversal intersecting two lines, and then in that diagram you notice that the corresponding angles are congruent. That is, it could be either this corresponding angle, I could have another corresponding angle here and another corresponding angle here. And if their measure is equal, for example, if this angle is 60 degree and this angle is also 60 degree, then you will notice that this line L will be parallel to line M. So this is the meaning of converse of corresponding angle axiom. Students, in the converse, the lines are not yet parallel. You're going to prove the lines to be parallel. It is a transversal that is going to intersect the two lines. And when the corresponding angles are congruent, then the lines become parallel. Okay, so now what we will do is we will look at a proof, that is how to prove the converse of alternate angle axiom. But before that, let us learn the meaning of converse of alternate angle theorem. The converse of alternate angle theorem. What will be the statement? There will be a transversal and there will be two lines. Children, the lines are not yet parallel. You have to prove them parallel. So what will be the statement? If a transversal intersects two lines and if a pair of alternate angles are congruent, then the lines are parallel. So look at the statement. If a transversal intersects two lines and if a pair of alternate angle is equal, then the two lines are parallel to each other. Let us learn how to prove this statement. Okay. Now prove the below given theorem. I want you to make a note of this in your notebook. Students, this is a very, very important question. So first you note down the statement. If a transversal intersects two lines, so let us take two lines M and N, and let us take one transversal T which is intersecting these two lines M and N, such that if a pair of alternate interior angle is equal, then the two lines are parallel. So what is given? T is a transversal intersecting two lines M and N, and A is congruent to B. So where do you think will be the position of A and B in this diagram? Will it be corresponding angle, or will it be alternate angle, or will it be interior angle? Look at the question. Such that a pair of alternate angle is equal. So where will A and B lie? This will be the position of A and B. They should be alternate angles. You could also take it here and here. That's your choice. Okay. So I've taken this as A and this as B, and A is congruent to B. You have to prove M is parallel to N. So with this, we begin the proof. Now, the clue out here is always take one vertically opposite angle either to A or to B. I've taken one vertically opposite angle to A. So how are you going to write down the proof? Look at the first sentence. A is congruent to B. Why is it congruent? Because it is given. And why is it given? Because it is mentioned that alternate angles are congruent. Okay. Then your next sentence will be A and C both are also equal because they are vertically opposite angles. Now compare statement 1 and 2. A equal to B and A equal to C. So what about B and C? They will be congruent from 1 and 2. So now look at B and C. Are they not congruent? Yes. Now this is how you're expected to think. B and C both are congruent. That means their measures are equal. If this is 120 degree, this is 120. This is 110, this is 110. Right? And what kind of angles do they look like? Don't they look like corresponding angles? Yes. So what do you have? You have a pair of corresponding angle that is congruent. So your next statement will be, but they are corresponding angles. Therefore, the lines L and M are parallel because of converse of corresponding angle axiom. So what is the converse of corresponding angle axiom? When a transversal intersects two lines, and if a pair of corresponding angle is congruent, they are corresponding and they are congruent, then what happens to those lines? Then those lines become parallel. So which theorem or which axiom we have used in this? We have used converse of corresponding angle axiom. So students, we are doing alternate interior angle theorem. But in this theorem, we are making the use of converse of corresponding angle axiom. Okay, so we are taking the help of this axiom to prove this theorem. I hope it is clear. I want you to understand this, make a note of this and write it down. I repeat again, T is a transversal intersecting two lines M and N, and you have to prove M and N is parallel. So first is you take a pair of alternate angles which are congruent. Now how do you know you're supposed to take alternate angles? Because it is given in the question that and if a pair of alternate angle is equal. So A is equal to B and you have to prove M parallel to N. The proof is either take vertically opposite to B or take vertically opposite to A. So I have taken vertically opposite to A, that is A congruent to C. And you already know A is congruent to B because it was already given in the sentence. Now when you compare it, you get B congruent to C. So immediately look at the diagram. B congruent to C. Oh, but they are corresponding angles. So I have proved corresponding angles are congruent. And when corresponding angles become congruent, the lines become parallel because of converse of corresponding angle axiom. Okay. Now let us look at another theorem, which is the converse of interior angle theorem. Until then, goodbye and take care.